In this lesson, you'll learn how to solve compound inequalities and solve absolute value inequalities. How are compound inequalities used in medicine? One test used to determine whether a patient is diabetic and requires insulin is a glucose tolerance test. Patients start the test in a fasting state, meaning they have no food or drink except water for at least 10 but no more than 16 hours. The acceptable number of hours H for fasting can be described by the following inequality. H is greater than or equal to 10, and H is less than or equal to 16. Now, if we are both greater than or equal to 10 and less than or equal to 16, that looks like a betweenness statement. That could be read, it's kind of H is between 10 and 16, but it includes the boundaries. But we have a nice, concise way of writing it with inequalities. So that's equivalent to the statement they made with words. It's just a little nicer mathematically. H is greater than or equal to 10, and H is less than or equal to 16. A compound inequality consists of two inequalities joined by the word and or the word or. To solve a compound inequality, you must solve each part of the inequality. The graph of a compound inequality containing and is the intersection of the solution sets of the two inequalities. Compound inequalities involving the word and are called conjunctions. Compound inequalities involving the word or are called disjunctions. The book shows two methods of solving this where they break it up. The first one is to break it up into two separate inequalities. I really prefer the second method. I'm not even going to show you the first. You can look at it in the book if you want to. I think you see undo minus 2, and we're just going to do it to each section of the inequality. So now I have 12 is less than or equal to 3y is less than 21. And then we can divide all three sections by 3. So we end up with 4 is less than or equal to y is less than 7. If we are to graph that on a number line, not bad, 0, there's my 4, there's my 7. I need a closed circle on the 4 because that is included, open circle on the 7 it is not, and connect the points. Y could be anything in between there. It could be 5, it could be 4.15, I don't know. For kicks and giggles, we mentioned the last lesson the interval notation. This would be written bracket because the 4 is included, and then parenthesis, the 7 is not. But even though the book mentions it, it only uses the familiar inequality symbols for this year. The graph of a compound inequality containing or is the union of the solution of the two inequalities. So in an or situation, our arrows can go opposite directions. So to solve, all we're going to do is solve each of the inequalities separately. We have subtract 3 from both sides, x is less than -1, or divide by -1, x is, we divided by negative, so, that's interesting, less than or equal to 4. That's unusual. The arrows are going the same way. So this is an interesting one to talk about. Since this is an or, only one of them has to be a true statement. So if we pick a number such as -2, that's going to be true for both of them. 0, however, would only be true for the second one, and that's okay. So in this case, our final answer is just going to be x is less than 4, because all values less than 4 are also less than -1. A graph would be closed circle on the 4, arrow goes to left. That's all we need for the number line graph. In general rule of thumb, it's always nice to have the variable first. I'm going to rewrite this. Absolute value of d is less than 3. Okay, so d stands for distance. We want the distance to be less than 3 units from 0. So our boundaries are going to be 3 and -3 and less than, so it comes together. In set builder notation, which is the one we're used to using, we could write this d is a number such that, okay, we want it to be -3, it's not included, d 3, and then the braces just mean it's all of those numbers. Now, in that funky new interval notation, it's actually less writing. We could write -3 to 3, and the parentheses mean the boundaries are not included. Once again, with the absolute values, absolute value can never be negative. So the solution of an inequality like the absolute value of A is less than -4 can't happen. Empty set. The solution of an inequality like the absolute value of A is greater than -4 always works. So it's a set of all real numbers. Okay, this time I'm going to rewrite it. The absolute value of D is greater than 3. So greater than, again, our boundaries are not included, but more than 3. Now this is a disjunction. They're going opposite ways. So all we can do to write this is just to say D is less than -3 or D is greater than +3. So that's our graph and our solution. If we wanted to write this in the interval notation, it gets interesting. So we have -infinity to -3 included, union with, this is the union, 3 to +infinity. We're putting them together. For all real numbers, A and B, where B is greater than 0, the following statements are true. If the absolute value is less than B, then A is between -b and +b. If the absolute value of B is greater than B, then A is greater than B or A is less than -b. So again, we have our case 1, case 2 scenario. So case 1, we're just dropping off the absolute value. And case 2, 2x minus 2 is less than or equal to -4. To solve, we're going to add 2 to both sides. So 2x is greater than or equal to 6. Divide by 2. X is greater than or equal to 3. Add 2 to both sides. Seems familiar. So 2x is less than or equal to -2. Divide by 2. X is less than or equal to -1. Now our inequality was a greater than, so we expect our number line graph to go out. So x is less than or equal to -1, or x is greater than or equal to 3. And there's no cool way of writing it like a conjunction. It's a disjunction, so it just gets to have the word or in it. According to a recent survey, the average monthly rent for a one-bedroom apartment in one city is $750. However, the actual rent for any given one-bedroom apartment may vary as much as $250 from the average. Write an absolute value inequality to describe the situation. Okay, so they made the expressions the absolute value of $750 minus R to represent the rent of an apartment can differ by the range. It can be around that $750 by as much, so it's as less than, not more than, $250. So now we get a solve. So case 1, we're just dropping off the absolute value and copying it down. In case 2, we have 750 minus R. We're doing the opposite, so it's greater or equal to -250. So we're going to subtract 750 from both sides. And we have -R is less than or equal to -500. When we divide both sides by -1, R is greater or equal to 500. Subtract 750 from both sides again. So we have -R is greater or equal to -1000. Divide both sides by -1, and I divided by negative, so it's going to change my inequality to less than or equal to. The problem didn't say to draw a number line, but just to help us visualize it, 250 less than 750 is 500, 250 more is 1000. So we could write that together as, it's a nice conjunction, so we could write 500 is less than or equal to R is less than or equal to 1000. Should have labeled those dollars. In words, we could say the actual rent is between $500 and $1,000. And I want to add the word inclusive because the ends are included. The graph of an and compound inequality is the intersection of the solution sets of the two inequalities. The graph for an or compound inequality is the union of the solution sets of the two inequalities. For all real numbers a and b, if b is greater than 0, the following statements are true. If the absolute value of a is less than b, then a falls between negative b and positive b. If the absolute value of a is greater than b, then a is greater than b, or a is less than negative b.